Hi, welcome. This is going to be a video covering the second part of linear functions from 8.4. We're going to start off today with finding equations of lines using slopes and a point. So we're going to use this formula, which is called the point-slope formula for an equation of a line. The point-slope form looks like this. You have this function y minus y1 with a subscript of 1 equals m times parentheses, make sure you put the parentheses, x minus x1, where m is, again, that will be the slope, just like in y equals mx plus b, and this x1 and y1 are going to be coordinates of a point on the line. So write that out here, coordinates of a point on the line. So it can be any point. So instead of just the y-intercept, you can have any point on the line. The x, this x, and this y are going to stay x and y, because remember, if you graph a line, there's an infinite number of xy ordered pairs. So when we can find out what y is when we know x, but it's going to be a relationship. It doesn't, there's not just one x and one y, so they're going to stay variables. So an example, let m equal negative 1/3, and x1, y1, a point on the line, is 4, 7. Find the equation of the line in point-slope form. So we're going to, this is our point-slope form. Kind of want to just memorize that. And then we're going to put it into point-slope form, and then we're going to rewrite it in slope-intercept form. So oftentimes you want to have an equation in slope-intercept form. You'll see tests where you have to do that, or it's just a really convenient way to have the equation of the line. So my point, x1, y1, here's my x1, here's my y1, and my slope m is negative 1/3. So all I'm going to do is substitute those values in here. So I still have this y minus my y1 value is this 7 right here. M is this guy, negative 1/3. And then I have x minus, the x1 coordinate is this 4. So x minus 4. So the negative is in the equation, the formula. And so it's going to be minus 4 and y minus 7. Okay, now to put this in slope-intercept form, this what I have right here is a perfectly fine equation of a line, but oftentimes you will have to put it in slope-intercept form. So let's go through how to do that. So you're going to want to distribute this negative 1/3 to both of those values over here. So we're going to have negative 1/3 times x is negative 1/3 x. A negative times this negative is going to be a positive. And 1/3 times 4, 1/3 times 4, you're going to, if you do this off to the side, you multiply straight across. So 4 times 1 over 3 times 1. So it would be plus, because remember it's a negative times a negative, 4/3. So don't worry about fractions. Fractions are your friends. Over here we have y minus 7. Now don't have it in slope-intercept form, because remember slope-intercept form is y equals mx plus b, where you have y on one side by itself. So I need to get rid of this minus 7, so I'm going to add 7. And I'm going to add 7 to the 4/3 because those are like terms. This is gone, and you have negative 1/3 x, and then 4/3 plus 7, well, I'm going to figure out what that is off to the side here. 7 I can make into a fraction by putting it over 1. And remember, when you're adding fractions, you have to find a common denominator. So my common denominator would be 3, so I'm going to multiply the top and bottom by 3. So then I have 4/3. Multiplying that together, you get 21/3. Adding the tops together, you get 25 over 3. So plus 25/3, which is a perfectly fine number. But if you were going to graph this, let me put it all in the same color. How about y equals negative 1/3, that's your slope, times x plus 25/3 is not something that necessarily automatically comes to your mind, like where that would be on the y-axis, because that's the y-intercept. So we could put it in a mixed number, and so 3 goes into 25 8 times. with 1 left over, so that's 8 1/3. So if you were going to graph it, you'd go on the y-axis to 8 1/3, and then the slope is negative 1/3, so you're going to drop 1/3. To write this in function form, it's simply just putting, instead of the y equals, the function form is just saying, well, I'm going to write it as this is a function that's dependent on x, so f of x equals negative 1/3 x plus, you can pick either one of these, 8 1/3 or 25/3. Both of those work. All right, so that's that part. The next part of 8.4 is just finding a linear equation given just 2 points. So now we don't have the slope, so now what we're going to do is we're going to choose which method we want. You can use slope-intercept form or point-slope form. But if you're just given 2 points, the first thing you need to do is find your slope. So remember, the slope is this equation. So I have these 2 points. I'm going to call this one point 1, so x1, y1. I'm going to call this point 2, x2, y2. I'm going to plug it into this formula. So you guys should do that on your own and come back. So you have 3 minus a negative 1 on the numerator, and then negative 3 minus 3 in the denominator. 3 minus a negative 1 means you're going to add the 1, got the double negative. 3 plus 1, which is 4, and then the negative 3 minus 3 is negative 6. So you got 4 over negative 6, which simplifies to 2/3, and the negative, hopefully you guys know this, but if you have a negative 4 over 6, it's the exact same thing as 4 over negative 6, or you can put the negative out front. Oops, that's supposed to be out front, not the 4. Those all mean it's a negative 4/6, but in simplified terms, negative 2/3. So then you can use either the point-slope form, or you can use slope-intercept form. I'm going to use, let's go with point-slope form. So point-slope form is y minus y1 equals m times x minus x1. M is what we just found, negative 2/3. And here's my, I'll just use this point since I called it x1, y1. It doesn't matter. You could use the negative 3, 3. But your y1 is going to be this negative 1, so y minus a negative 1. Your slope is negative 2/3, so I'm putting that in for m. And then x minus x1 is 3. So this becomes, I'm going to go over here, I'm running out of room, minus a negative becomes plus 1. And then you can distribute this, because we're going to graph this. We don't even need to do this, but if you wanted to put it in slope-intercept form, I could distribute this, negative 2/3 times negative 3, make that a fraction. Got a negative times a negative, which makes it a positive, and 2/3 times 3 becomes plus 2. Oh, this has an x. I'll put the x here. Negative 2/3 x, and then plus 2. Subtract the 1 to get it in so that y is on one side by itself, and I get, oops, I'm going to go over here. Y, because this is 0, so it's y plus 0. And then equals on the other side, subtracting the 1 from the 2, I get negative 2/3 x plus 1. So I'm going to graph this using the slope and y-intercept. The y-intercept here is 1, since this is a slope-intercept form. The slope is negative 2/3, so I'm going to go down 2 and over 3 to get the second point. You can also go up 2 and to the left 3. We just got to make sure that's, you've got a negative slope. Had I not done all that work and I stayed with this, then I could also graph that point pretty easily. I'm going to graph the point that we started with, which was, okay, 3, negative 1. So 3, negative 1 is that point right there. And then I have a slope of this negative 2/3, so I can go from this point instead of from that point, which is what we did with slope-intercept form. For point-slope form, I'm going to go to this point and I'm going to go down 2 and over 3, and you end up right back on that line. Or if you went up 2 and back this way 3, you end up on the same exact line. Doesn't matter. And it doesn't matter if you would have used the other point, this one, 3, negative 3, negative 3, 3. If I go to negative 3, 3, that's that point right there. I could have used that point and then did the slope of -2/3, which would have brought me to this other point, and I'd still have that same exact line. Okay, the last part of this 8.4, probably I'm going to say is the most challenging. It's piecewise functions. So piecewise functions is when you have a break in the graph, and it doesn't necessarily have to be discontinuous, but you're going to have on one side of the graph one equation, and on the other side of the graph a different equation. So this is saying that f of x is going to equal x minus 1, or y is going to equal x minus 1 for values of x that are less than -1. And then we're going to switch to a different graph. We're going to switch to 2x plus 3 for values of x that are greater than or equal to -1. So where it's going to split is this part right here, where it goes from one function for values less than -1 to a different function for values greater than -1. So if I just put a dotted line here, this is not part of the graph, but if I put a dotted line at -1, that's going to be my reminder that something's going to happen at -1. Okay, so I know that the function is going to look like the graph of x minus 1 for values of x that are less than -1. So when I'm going to make a table of ordered pairs. You don't have to do this if you know how to graph it without that, but if you're not sure, you can always make this table of ordered pairs. And because I'm looking for values of x that are less than -1, I'm going to pick values of x that are less than -1. But I'm actually going to start at -1 because I want to know where it's getting closer to when we get closer to -1. And then I'm going to, oops, 0 is not less than -1, so I don't want that value. -2 is less than -1, -3. And if you look at this function, y equals x minus 1 is linear. So I only really need 2 points. I'm going to put 3 on there. But when x is -1, if I put it into this function of -1 minus 1, I get -2. If I put -2 in for x here, I'm going to get -2 minus 1, which is -3. Then putting in -3, I get -3 minus 1, which is -4. So I'm going to have these points. I'm going to graph -1, -2, which is right here. I'm going to put an open dot there because it's not included, because this is only going to be the graph when x is strictly less than -1, not including -1. So if you remember graphing on a number line, it's an open dot if it's not included. And then I'm going to plot the rest of these points. So after I plot the rest of the points and I draw it in, I'm going to have this line right here, and it continues forever in the negative x direction, but it stops right here. So I'm going to stop using that function, and now I'm going to switch to this function. So we graph this guy over on the left side of -1 because it's for values of x less than that. Now I'm going to switch to values of x that are greater than or equal to -1. So I'm going to start with -1 because I want to know where it starts out, and then I'm going to go bigger values than that. So I really, again, this is linear, so I really only need 2 points, but I'm going to do a few more than that. You guys evaluate. You're going to put in -1, then put in 0, 1, and 2, and then graph it, and come back. So I made the table, and then I graphed the points -1, 1, which is right there, 0, 3, which is right here, 1, 5, and then 2, 7 goes off my graph, but it's somewhere up there. And it's a line, and it's going to go like this. It's going to go forever in that direction because it's for values of x that are greater than or equal to -1, so forever in the positive direction. But it stops when you're moving to the left. It's going to stop right here because it switches to this other function at that point. So this is what, oops, that was supposed to be yellow. The yellow is going to be on the right side of -1, the other is on the left side. So here's another example. Why don't you write it down and see if you can figure out how this works. I'm going to pause the video and do it, and then you come and check. Okay, so the green graph is the graph of f of x equals -2, which is a horizontal line. The blue graph in the middle is when x is between -2 and 2 and it's equal to the value of x, and then the purple graph is x equals +2.